So you wanna time travel, but if you watched enough movies and TV shows, you probably know it's not that easy. And even if you did, yeah, a lot of problems tend to happen. So let's go through how you would go about it. Whether you want to travel to the past or the future, or maybe switch timelines or send a message back in time, all of these fall into two major categories: time dilation and time warping. Let's go to time dilation first. There are two ways to experience time dilation. First is through velocity by Einstein's theory of special relativity. Basically, as three-dimensional beings, we experience time in a linear motion, which means for us it always seems that time is going forwards at a constant rate. But not all of us experience it at the same level. Depending on your velocity in regards to how fast you are going in contrast to the speed of light, you will experience time at a different rate compared to those who are stationary in motion. Which means if you spent 1 year in a spaceship at near light speed, around 99.999%, and then come back to Earth, time on Earth would have passed over 220 years. Now, there are some theoretical ways we can achieve near light speed travel, which would require either using a tremendous amount of energy or literally warping space-time itself. Now, if you want to warp space-time, you should probably look into the Alcubierre warp drive. I mean, just look at this thing, bro. Imagine pulling up. But this kind of vehicle would require exotic matter. Matter with negative mass and negative energy, which means gravity repels it rather than attracts it. This would allow the space behind the spacecraft to contract as the space ahead of it expands, creating a sort of bubble around it, which means the spacecraft would sit inside the bubble while the warp in space-time creates a sort of wave that allows the craft to cruise without feeling any acceleration, a process that would allow this vehicle to travel faster than light, without violating the laws of special relativity. Well, apart from the fact that it violates pretty much everything else. And although a cool concept, exotic matter doesn't really exist, or at least we haven't found any yet. But there might be another way. By looking at Einstein's equation of E equals mc squared, we already know that immense amounts of energy is present in all of matter, but being able to harvest usable energy from it is the challenge. Thing is, the closer we are to light speed travel, the more energy we would need for propulsion. So, we need to harvest as much energy as efficiently as possible. Fortunately, there is a way to extract 100% of energy from matter, using not just any explosion, but antimatter and matter annihilation. And unlike exotic matter, antimatter is real. If contained and done in a series of explosions, this could generate thrust at a fraction of light speed travel, assuming that your body won't turn into mush. Anyway, time travel through near light speed is the boring way. If you time travel like this, you're just a pathetic loser, man. Let's time travel like a mad scientist, using the second way to utilize time dilation, aka via black holes. More specifically, Kerr black holes. Hold on, but to get to a black hole, we would need a near light speed spacecraft anyway. So why would we need to visit a black hole when we can just use time dilation through near light speed travel? Boy, if you don't get... Okay, now that we got that out of the way, what is a Kerr black hole and why is it important? Kerr black holes spin, and they have a singularity in the shape of a ring. In truth, most black holes are probably Kerr black holes. The famous photo of a black hole taken by the Event Horizon Telescope is a supermassive Kerr black hole. The spin of a Kerr black hole is key to achieving time dilation, because everything outside the event horizon warp, drag, and stretch due to the spin and the immense gravity, meaning the fabric of spacetime itself is being stretched, causing a significant time dilation. This area is called the ergosphere. And since this area is not in the event horizon, the point of no return, you can still escape it, which means you can simply visit the ergosphere and it will fast forward you into the future. Now, there's another way to skip time by freezing yourself and waking up later on called cryonics or cryogenic sleep, but that's also a lame way of time traveling. Like, honestly, I'd rather die traveling in a black hole than freeze myself like a popsicle. Okay, cool, we can time travel into the future now, but what about the past? Or at least send a message to the past, or switch timelines. Now let's talk about time warping. Traveling all the way to a black hole would be such a hassle. So what if we could just create our own black holes? Oh wait, you can! Yo mama's so fat! I'm just kidding. But for real though, we may or may not have created some miniature black holes already. CERN, the European Organization for Nuclear Research, owns the largest Hadron Collider. In theory, high energy collisions could result in really tiny black holes, probably smaller than a proton, but these would most likely evaporate just as soon as they appear. We actually haven't proven their existence either, since even if they do appear, it would be very hard to detect them in the first place. But what if you are a mezzo scientisto with a ton of free time and money, and you were able to develop, research, and create feasible black holes that are harmless but exist big enough to contain and to research? You could be on your way to send a message to the past. But how? You see, curved black holes come with a ring singularity, which means you could try and pass through the singularity without ever being in contact with it, and possibly use the black hole as a wormhole to another universe or another time. Generally, curved black holes are strong candidates for a time loop in space-time, using it as a wormhole. But then the event horizon would stop anything traveling through it. Unless we talk about white holes, but that's an entirely different hypothetical field altogether concerning other universes, so we're not gonna get into that. But let's say you were able to experiment on a black hole enough to maybe create a possible wormhole that connected to another time in the past. If it is small and evaporates in a heartbeat, you probably should not try jumping into it. Unless, of course, you're a cave diver. Instead, try sending a message through it. Chances are data might be able to travel inside, but it won't be able to get out, considering how a black hole traps everything that comes through the event horizon. But there might be a way. Now we're getting to some quantum physics and particles, and things get really weird from here. Black holes actually emit radiation according to Stephen Hawking and his theory of quantum mechanics and Hawking radiation. Basically, it suggests that virtual particles that come in contact with the event horizon splits, causing a part of it to enter the black hole and the other part emitted as radiation. Here's the crazy part: in the vacuum of space, virtual particles always spontaneously pop into existence and evaporate almost at the same time. These particles contain an electron and a positron, and they seem to just appear out of nowhere and then disappear just as quickly. And though we can't directly detect it given how small and brief it is, we still observe its effects. Think of virtual particles as a thing popping out of nowhere, borrowing energy from somewhere. Where, you ask? Nowhere! Because quantum physics doesn't give a damn about anything and just does whatever the heck it wants. That said, when virtual particles come in contact with the event horizon of a black hole, either one of the electron or positron falls in and the other gets shot away as radiation. So now, instead of evaporating, they continue to exist. That means something just got created out of nothing. How? Quantum physics, bro! Ain't nobody know how that thing works. Actually, virtual particles is just the result of the Heisenberg uncertainty principle concerning uncertain particle behaviors. Yeah, basically it means we don't really know how or why the heck it happens, but it happens. That's why it's uncertain, and that uncertainty is exactly the principle. Yeah, I know, it makes a lot of sense. Anyway, if you were able to translate data into gravitational fluctuations for the mini wormhole inside the mini black hole, as it connects to the other side and fluctuate the same way, you could try using the radiation emitted on the other side to be translated back as data, meaning that you just sent a message back in time, assuming that the wormhole doesn't collapse in the process. Now this comes with a lot of caveats and paradoxes. If you were able to succeed in sending a message back in time, would you alter the reality of your timeline or create a new timeline? And if so, you probably won't retain your memories anyway. So even though it might work, there would be no way to prove it. But what if you want to transport yourself inside of a wormhole instead? You would need a traversable wormhole. Not the kind that would require a black hole, because then the event horizon and singularity would just eat you up. But traversable wormholes also require exotic matter. But let's say somehow you were able to obtain exotic matter. You might be able to construct a traversable wormhole. First, we need to bend spacetime into itself. Normally this would result in a black hole, but if you're able to place exotic matter at the throat, this would allow the wormhole to stay open with its anti-gravitational properties, resulting in a traversable wormhole. Now of course, wormholes are highly theoretical, and even if they do exist, specific extreme conditions need to be met for it to be stable. But anyway, if you're a mezzo scientisto at CERN with nothing else to do and somehow be able to contain and research black holes, maybe you can start building a time machine yourself. Now because time and physics are woven in such a fine-tuned way, apart from quantum physics that doesn't really give a damn about anything, there's really no room for errors. Time travel to the past would suggest many time paradoxes, and it's possible that the simple answer is that time just won't allow for it. But I'll be talking about paradoxes in my next video.